So it is really a fantastic evening today this side. Wherever you are watching from, you are again welcome to our fourth video in the series. As usual, we shall be using chemistry, and we shall not be resuming because we are actually looking at the different parts of the pipeline. So last time in our previous video we covered how we can choose a topic and how we navigate, and we saw how this interface enables us to incorporate videos and images to the very best, not like say when you'd use a Word document it is fantastic, but you're not ever gonna have a video where you need it. When you come to PowerPoint it's really good, but it's meant for belief work, even the videos, incorporating it is very much harder. So basically that was something fresh taking for those people who actually paid attention to that part. So now we're going to look at the next. We shall follow order. So today we shall be covering the first option, where is Z. What happens when I enter Z? Fantastic, I'm going for an adventure. So in an adventure I will choose a chapter I'm interested in. So maybe today I'm interested in which adventure should I take on? Let me, for example, take on the adventure of air. Air is harder, So first of all, we shall welcome you to that adventure, and you're supposed to discuss whatever question that is given to you in our adventure in groups and come to a single conclusion. So basically this is how our adventures are actually set up. In the future we need to modify how we set this, how the application chooses these items, but now we are more interested in showing how this adventure works basically. So we shall give you a question, then you answer it, and when you answer it, it will be looked at by the model, and then you get compliments. Of course the answers are predetermined, so it's not the model that is choosing what is right and what is wrong. It's actually the model that is complimenting you on why say you are wrong, or maybe on why it is right, for better understanding. So here you will not call it up, but it will come in, and it will come in a better way, in an adventurous way. So it's like you are answering questions, and then when you fail, we actually find a way to console you, and then maybe give you more advice. So here previously we are determined when you're doing an adventure, it means you have already read the topic you're doing an adventure in, and depending on how it has been set, we shall ask you whether whatever statement provided is right, or if it is only one that is right, or if all are right, or if all are wrong, if none is whatever, depending on how it is set up. So that is meant to make sure actually you have read the chapter. It's like a way of reading the notes, but in an interactive way. If, for example, you never wanted to read the notes the other first way we said, whereby you are reading by pressing enter, getting the video there, that is fantastic, but this is also another way that is going to test whether actually you read the notes. This actually is testing for your proper understanding. That is very fantastic. So it requires internet because you are talking to the model. So the next option we shall also cover today is the revised part. The revised part is using a similar actually set of questions, and whatever question you do here is saved, it never comes back. So you rather do it and learn it. It will only come back when all the questions are over, which likely is not going to happen because there are always many. Fantastic. So whatever you read is a one time. You need to save it. When you feel you have to write it, then you have to write it. So here you are looking at a model that is going to talk to you directly. That is Fun Adventure, and the reverse Fun Adventure we shall see today is the revised part, whereby you don't need the model, but you will be marked. Yeah, fantastic. So I'm going to answer this one. I'll answer two and see how we mark them, and then call it. Then we go to the revised part and see it. Then we call it a session. So I'm going to read the statement per statement, and then my final question is: are all those statements right? Meaning I need to read each and confirm it is right. Otherwise, if I just press yes, I may press yes when some of the questions are not right, when some of the statements are not right, and that would be actually dangerous, very dangerous. So the first statement is: the atmosphere is a layer of air surrounding the earth. Fantastic, that is right. Air is a mixture of gases. Perfect. Its composition varies at different times and in different places. Perfect. Air is a mixture, not a compound, because it can be made by mixing nitrogen and oxygen, and its formation is not accompanied by energy changes. That is right. The nitrogen and oxygen and other gases in air can be separated from each other by physical means. Fine. The properties of air are just the average of the properties of nitrogen and oxygen. Fantastic. The proportions of nitrogen and oxygen and other gases in air are definite. They don't vary from place to place and from time to time. I don't know whether they are, what even that means. The proportions of nitrogen and oxygen and other gases in air are definite. They don't vary from place to place and from time to time. I think they are. I don't think the proportions vary. I don't know. But for me, I say all the statements are right. So I will say yes. Then I will expect what so fantastic. I got it wrong. Unleash your inner comments and transform every challenge into a golden opportunity. Basically, I failed, and they're trying to say, when you fail, it's a golden opportunity. You come back and bounce back. So the statement that the proportions of nitrogen and oxygen and other gases in air are definite, they don't vary from place to place and from time to time, is demonstrably false. Atmospheric composition fluctuates with altitude, humidity, pollution levels, and geographical location. The proportions therefore are not definite. That is very fantastic. They are giving me a reason why I have failed, which is very good when you come to an adventure. If I had chosen to revise, we shall not contact our adventure. When you fail, you're supposed to figure out why you failed. Yeah, but we also give you an option whereby you can still connect to the internet and ask why you have failed. So fantastic. I failed that. I continue. My current score is 0. I get a next question. So when a mixture of magnesium, they are saying, could all these statements be true? Again, they want me to see whether all the statements are true, meaning I'm going to read each statement at a go. This will enable me understand my notes to the perfect. This enables you to understand content to its fullest capacity. So when a mixture of magnesium and cobalt oxide is heated, a red glow spreads through the mixture, leaving a white ash and a brown solid. Fantastic, that is right. Magnesium removes oxygen from copper to form magnesium oxide. Fantastic. So when a mixture of carbon and cobalt oxide is heated in a test tube, a brown solid is formed and the colorless gas that turns lime water is liberated. That is true. So carbon is therefore more reactive than copper. That is also true. So magnesium burns in carbon dioxide to form a mixture of white ash and black solid particles. That is right. So magnesium is therefore more reactive than carbon. That is also right. So could all these statements be true? Yes. I should get this right because it would be funny. Right, yeah. So the first expanse of chemical post-base awaits you. Dive in with Z. It's like we give you motivation. So it's like we are going all through. So all the statements can indeed hold true. The experimental evidence supports the relative reactivity series. Magnesium is more reactive than carbon, more reactive than copper. The reactions described exemplify displacement reactions, where a more reactive metal displaces the less reactive one from its oxide. Each reaction confirms the relative position of the elements in the reactivity series. For example, magnesium reacts with carbon dioxide, implying that magnesium is more reactive than carbon. Thus, the carbon has been displaced to leave a black solid. So this is fantastic. It actually gives you an explanation for why you got your things wrong or why you got your things right. Very fantastic. It enables you to make sure you have understood. That is proper understanding of content. So when you want to ask again, you'll ask, but if you don't want, you press 2 and come back. My current score is 1. When you get something right, we don't ring a bell. When you fail, we ring a bell. So basically you continue like that. Then here there is a question. Sulfur melts and then burns with a bright blue flame, forming cloudy white fumes with a pungent choking smell. That is right. The gas formed is a mixture of sulfur dioxide and sulfur trioxide. Fantastic. Is it true that the sulfur dioxide and sulfur trioxide dissolve in water, forming sulfurous and sulfuric acid respectively? Yes. You continue like that, So basically, yeah, they give you a bit you read, and at the end they will say, yes, you're right. Sulfur dioxide and sulfur trioxide do indeed dissolve in water to yield sulfurous and sulfuric acid respectively. So that was very fantastic, So my current score is 2. So you continue like that until the very end. So I'm going to close for now and open again to show you how it is different from the revised part, but taking similar set of questions which we intend to improve in future with support and understanding, so that these questions are actually reflecting what is really set in the items for our students. But for now, you see the logic. You can really appreciate. So if instead of Z I went for R, I would choose, for example, again air as my chapter. It would be the same thing. By this time we shall not involve AI, meaning you don't need internet for the revised part. Internet is not going to tell you why you have failed, why you have not. So it's up to you to check whether you are really online. So a hydrocarbon is a compound containing hydrogen and carbon only. Fantastic. Examples include candle, natural gas, petrol, paraffin. That is right. Is it true that when a hydrocarbon burns, water and carbon dioxide are produced as the only products? It is true. Yes. You nailed that. Your current score is 1. We are not going to give you internet. We are going to just continue like that. I hope that is clear. Yeah. To determine the percentage of volume by oxygen in air, Williams put some copper turnings into a combustion tube fitted to 2 cylinders. He sucked air into one of the gas cylinders up to 100 centimeters and plugged its mouth with cotton wool. Is it true that the cotton wool allows air to easily be blown from one cylinder to another without the copper turnings entering the cylinders? I think yes. My current score is 2. Peroxides are oxides that contain twice as much oxygen as they would contain in their normal oxide. That is right. Examples include sodium peroxide, hydrogen peroxide, barium peroxide, and potassium peroxide. So peroxides except hydrogen peroxide react with dilute acids to form hydrogen peroxide. Is there any false statement? Eh? Peroxide is the oxide that contains twice as much. That is right. Examples include that. Are those formulas right? Yeah, I think they're right. Peroxides except that react with dilute acids to form hydrogen peroxide. That is wrong. That should be wrong. I think no. You got that right. Yeah, I'm right. That is wrong. You can't again form a peroxide after reacting with an acid. Fantastic. We go on. So which of the following processes does not reduce the amount of oxygen in the atmosphere? Reduced amount of oxygen in the atmosphere. We have germination, photosynthesis, combustion, and respiration. You know, germination is where you are reducing oxygen, you are breaking down food for the seed to germinate. Photosynthesis is not utilizing oxygen, actually it is producing oxygen, so it has to be brilliant, you know. I'm brilliant that I got it right. So like basically I'm trying to show you how this works. We can change these questions. It's a matter of appreciating that, you know what, yeah, you can be assessed offline. Fantastic stuff, eh? Very easy. So aluminium and zinc are shiny metals, although their surfaces get coated with thin layers of their respective oxides on exposure to oxygen. That is right. Aluminium and zinc react more slowly with oxygen than magnesium, forming their oxides. That is right. Hence, aluminium and zinc are less reactive than magnesium. Everything should be true. I'm a living success story, you know. I have a current score which is 5. I want to finish up this and then see what happens at the end. So the question is, I usually first look at what they want at the end. Do all these statements make sense? All those statements make sense. The first statement is some of air pollutants include burning of fossils such as coal, coke, and oil to produce oxide of carbon and sulfide and unburnt oil vapor. That makes sense. Industrial and domestic depositions that produce oxides of carbon, sulfur, sometimes methane and other heavy metals like mercury. That makes sense. The exhaust fumes of locomotives, e.g. cars, that contain carbon monoxide, carbon dioxide, nitrogen dioxide, and burnt fuel, and some heavy metals like lead. That makes sense. Nuclear explosions that produce radioactive particles. That makes sense. Tobacco smoking, fantastic, it causes pollution. Natural processes like volcanic eruption, do they cause air? Are they sources of air pollutants? Yeah. And gases reduced from manure in farmland. Yeah, those cows, that manure. All those statements make sense. Fantastic, they all make sense. I'm a true asset. Then this one is oxygen can be prepared in the laboratory from oxygen-rich compounds such as hydrogen peroxide, potassium chlorate, potassium permanganate, and sodium peroxide. That is right. On a large scale, oxygen is prepared by electrolysis of sodium hydroxide and fractional distillation of liquid air. That is fine. During fractional distillation of liquid air, is it nitrogen that distills off rust? How? When you look at fractional distillation of liquid air, you remember nitrogen is what is actually going to distill off fast, because it comes at negative 196 degrees Celsius. That's what I'm assuming. So I'm going for no. I'm a true asset because it is actually the first that distills off. So when a metal burns in air, there's an increase in mass. Is the increase in mass due to the fact that the metal combines with oxygen of the air to form an acidic oxide? No. The increase in mass is due to the fact that the metal combines with oxygen of the air to form a basic oxide, not an acidic. An acidic would go for a non-metal. So it's no. That is it. I'm very fantastic. My current score is 8. So lead melts into shiny beads and finally forms a yellow powder of lead 2 oxide when cold. Fantastic, that is right. Is lead oxide usually reddish brown when hot? Colors. Fantastic, it's usually reddish brown when hot. Is there anything I can't do? Is there anything I can't do? Then rusting is a chemical change in which iron combines with water in the presence of air to form a reddish brown substance. That is right. So rusting corrodes and wears off iron and reduces its strength. Fantastic. It is a slow process. Right. Is the chemical formula for rust that? That is the chemical formula. But I'm going to resist and say no. And they will tell me I'm wrong. At least let me fail one thing. So when I'm done, what happens? Yeah, so when I'm done, what happens is finally my score is I got that covered. They were supposed to give me hands. I don't know why they are not clapping for me, but maybe it's an issue with my PC. But after you have passed like this, we should clap for you, dance for you, you know. And when you fail, we are supposed to actually to laugh at you, which is a bit funny. Yeah. Then after you can record your results. If you don't want, you can choose to refuse. When you record, it is very important. The next time you can track, everyone can track how you are progressing, whoever uses your PC. Very fantastic stuff. So I may say I'm going to record as that is my name. So the obtained score has been allocated. So congratulations, I've successfully completed this. Do you want to try? If you get below 8, we automatically give you another set of instructions. You have failed, but when you pass, we ask you actually whether you want to try again. I don't want. I'm fantastic. I entered. Yeah, so I'm going back to my class. So that is it for today. We looked at Z for an adventure and R for revising, and we are looking at how really that is fantastic. Really fantastic stuff. Thank you for again viewing this, and hope you can go on and use it and enjoy, you know, and work together so that we can have everything in one place. Thank you and have a nice time.